Now we are going to learn about midpoint theorem, Euclidean geometry, part 21 of 25. Okay, so the midpoint theorem states that the line segments connecting the midpoints of two sides of a triangle is parallel to the third sides and half its length. So you have triangle A, B, C. D is the midpoint of AB. Okay, so AD is equal to DB, and E is the midpoint of AC. So AE is equal to EC. So if you have a line segment connecting the midpoints of two sides of a triangle, okay, connecting the midpoints of two sides of a triangle, the line is parallel to the third side, parallel to BC in this example, and the line is half its length. So DE is equal to 1 over 2 times BC. We are going to see that. So you have DE parallel to BC, and DE is half its length, half the length BC. Okay, so this is the midpoint theorem. Now, the converse of the midpoint theorem states that if a line is drawn through the midpoint of one side of a triangle and is parallel to another side, it will bisect the third side. Okay, you have a triangle ABC. Okay, so if a line is drawn through the midpoint of one side of a triangle, the midpoint of AB is D, and the line is parallel to another side, it will bisect the third side. In this example, the third side is AC. Okay, it will bisect the third side. So AD is equal to DB, and AE is equal to EC. So AE is equal to EC. Okay, now using what we learned in lesson 20 of 25, we can come up with different ways of writing the proportionality equation. Okay, so please check lesson 20 of 25. Okay, let's write the proportionality equation. Okay, I'm going to use some colors so that you can see. So I can say AD over AB. Okay, AD over AB. Okay, AD over AB. This is equal to AE over AC. Okay, AE over AC. Since you have the entire sides AB and AC, you can include the two parallel lines. So you are going to have DE over BC. So you have a smaller portion, okay, a smaller portion over the entire sides equal to a smaller portion, okay, a smaller portion over the entire side equal to the smaller part over the bigger part. Okay, so smaller over bigger equal to smaller over bigger equal to smaller over bigger. Okay, do not swap around. This is equal to 1 over 2. This equation can also be written like this. you can flip this. Instead of AD over AB, you can have AB over AD equal to, instead of AE over AC, you can have AC over AE equal to, instead of DE over BC, you can have BC over DE. Okay, so this is equal to, you're going to flip, you're going to have 2 over 1, which is 2. Okay, or you can also have DB over AB equal to EC over AC. Okay, so you can have DB over AB equal to EC. Okay, so EC over AC. Okay, over AC. So since the entire sides are included, you can include the 2 parallel lines. Okay, so this is equal to, I'm going to have BC over DE or DE over BC. Okay, you are going to have DE over BC. You have to see that you have a portion of the sides over the entire sides. Okay, a portion over the entire sides equal to a portion over the entire sides. Okay, smaller over bigger, smaller over bigger. Okay, so smaller. Okay, DE is smaller as compared to BC, so you're going to have smaller over bigger. Okay, DE over BC. So this is equal to 1 over 2. You can also write this equation if you flip. Instead of DB over AB, you can have AB over DB equal to AC over EC equal to BC over DE equal to 2 over 1, which is 2. Okay, so remember to include the 2 parallel lines DE and BC. Okay, DE and BC, to include the 2 parallel lines in the proportionality equation. Okay, in the proportionality equation. Okay, the entire sides AB and AC. Okay, AB and AC, the entire sides must be included in the proportionality equation. Okay, so in conclusion, DE is equal to half of BC, or BC is equal to 2 times DE. Okay, so we are done.